right there and change that. Good morning, everyone. It is a rainy morning in North Texas. I woke up this morning, the clouds were rolling in. I had my dog outside and it started to rain. She was looking at me like, "Can I come in now?" So hopefully the storm, and it stopped now, but it's still kind of cloudy and a little bit cooler outside than it was yesterday and the day before. Hopefully the rain and storms that may be rolling through will not interfere with us. So I'm Jason, KC5HWB. I'm going to bring Chris on here in just a second. This is the third part of the live stream for the new technician class. We did the first part Thursday night, the second part last night. This will be the conclusion. Part 3, all videos will be playable on YouTube after the fact. Like any other uploaded video, you'll be able to go back and watch them as many times as you want. You'll be able to leave comments in the live stream chat while the chat is going today, and after the stream ends today, you'll be able to comment on the video. And I try to keep up with all the comments on all my videos on my whole channel, so please feel free to reach out via YouTube comments anytime today or after the fact. We got Frank Tank in the house moderating today. He's the only one I've seen come in there so far. We might have Noel and a couple of the other YouTube bunch guys come in there in a minute. So got about 36 watching right now. And we are going to get started here in just a second. So once again, questions at livefromthehamshack.tv. You're welcome to ask questions via email. Put your questions in the chat. If we cover anything that you think might be some, yesterday and the day before, we had a couple of guys in there who were already licensed, general and extra licensed guys. Maybe you've been a ham for a long time and had some questions come up about some of the wording on some of the questions. Just remember that this is taken from the question pool. And the question pool is not always 100%. It's probably 98, 99%. But some stuff may be kind of worded kind of weird. Just know this is the information you need to pass the test. And if there's something that you think is wrong, there are ways to contact the creators of the question pool about that. So just an FYI. Chris, I'm going to bring you in here real quick. Good morning. How are you?
Good. Good morning. Round 3.
Round 3. Round 3. Fight. So, all right, good deal. So we're going to go ahead and kick this off here, guys. Once again, ask your questions in the chat. Feel free. Chris, you can go ahead and share your screen if you like. Make sure that comes through correctly. Yeah, that looks good.
There we go.
Perfect. All right, the floor is yours.
All right. Well, good morning. Welcome to session 3. Hope you've enjoyed the first 2, and hope you've been doing some more practice tests after we finish each session. So today we're going to get into some more of the technical things, and we're going to go into antennas and then safety. So it's going to be a good session. This is my favorite session. So let's get right into it. All right, so we're going to start with some electrical principles this morning. Conductors and insulators. If you look at this, some of the conductors, usually the best conductors are gold, silver, copper, aluminum, and steel. You'll oftentimes find antennas made of either steel, aluminum, maybe some copper wire. Gold and silver are usually a little bit too expensive for antennas or anything like that, but they make good electrical components and good electrical contacts inside your radios, and you'll oftentimes find all 5 of those in your radios. Some of the poor conductors, insulators will be air, mica, paper, fiberglass, wood. Basically, anything that just does not conduct electricity well it will be considered an insulator. So some some of the different terms that we're going to cover, we'll be talking about electrical properties. So we're going to start with current. This is going to be the amount of electricity flowing through a conductor. Current is measured in amperes. This is kind of what does the actual work. Voltage is the pressure of the electricity flowing through a conductor. So you see a 9 volt or a 12 volt or 120 volts. This is going to be the pressure. It's like the push, the energy that's pushing the current through a wire. Your resistance is going to be the opposition to electricity flowing through a conductor. It's measured in ohms, and so you can think of if you have a water hose and you clamp down on the hose while water's flowing. Water has a hard time flowing through the hose. That's going to be your resistance. And then power is going to be measured in watts. It is the amount of energy consumed by something attached to a conductor. How much power or how much energy is going to be consumed. So the measurements of voltage, current, resistance are made with the meter. Volts are measured with the voltmeter, ohms with an ohm meter, amps with an ammeter, and then watts with a wattmeter. And then usually you can find all of these combined into one box and called a multimeter. If you're going to use one of these, make sure your settings are on the correct settings, because if you try to measure ohms while it's set to volts, you will toast your multimeter and it won't be any good anymore. So electrical flow is similar to the flow of water. So we have this water hose filling this bucket here. The hose is your conductor. That's going to be your wire. The size of the hose is going to be your resistance. The water pressure coming through it is going to be your volts, and then the actual gallons flowing, that's going to be equivalent to the amperes. They are all interrelated. They're all connected together, and they all come together to give us what we're used to seeing, to the electrical circuit that we're used to seeing. Ohm's Law defines the relationship in a circuit between power, voltage, current, and resistance. So that's P for power, E for voltage, I for current, and then R for resistance. And you'll see those used more here in just a couple of minutes when we get into some of the charts. The universal truth that it takes 1 volt to push 1 amp through 1 ohm. Providing a method to calculate the values or ratings of the components in a circuit, such as the value of the fuse you need for your radio, or the rating of a power supply for your station. Some radios, you may have to do that calculation yourself. Not often, but that does still happen occasionally. So E equals I times R. Voltage equals current times resistance. And one way that you can represent that is by using the little magic circle here. And I would recommend memorizing this, and then whenever you go to take your test, flipping your answer sheet on the back, drawing that circle, and filling it in with this information right here. Because you can do that. You can use this as a reference. You just have to turn in anything that you write on has to go with your test. So in this circle, you're able to calculate any of these values that you need. So in this one, V equals A times O. So there's your V up on top, and then A times O. If you want to find amperage, and it's going to be voltage times ohms, and then ohms equals voltage divided by amps, and that will give you the proper calculation method there to be able to find those values. You just cover up the unknown value and then use the chart, whether it's a multiply or divide, and that'll give you what you need to know. So going back to looking at this, what would the resistance of a circuit that draws 4 amps from 12 volt source? 4 amps from a 12 volt source. So we'll just plug in the 4 into or we're looking for amps. What are we looking for? 4 amps from a 12 volt source. We'll just plug that information in, and then we can come up with 3 ohms. So it all works together there to this is kind of a cheat sheet right here, so you can find out these without having to memorize the actual individual steps and everything like that. So what is the resistance of a circuit for which the applied voltage is 12 volts and the current flow is 1.5 amps? We'll just fill in those values there, and we'll get 8 ohms. So it's just simple math there, and you'll get the answer that you're looking for. What is the resistance in a circle in which current of 3 amps flows through a resistor connected to 90 volts? Again, we'll just plug those in. We're going to get the answer of 30 ohms. So, like I said, everything, you can use this little chart to figure out any of the questions that are asked. It can't hurt also to memorize that. So it's a very good brain jogger or mind jogger there, memory jogger. There we go. So what is the current flow in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? Just pop those in there. And we're going to get about 1.5 amps. Not about, we'll get 1.5 amps. And what is the current flowing through a 24 ohm resistor across 240 volts? 10 amps. What is the current flowing through a 100 ohm resistor connected across 200 volts? That'll be 2 amps. And what is the voltage across the 2 ohm resistor if a current of 0.5 amps flows through it? 1 volt. And then what is the voltage across a 10 ohm resistor if a current of 1 amp is flowing through it? I'm going to multiply it there and get 10 volts. And what is the voltage across a 10 ohm resistor if a current of 2 amps flows through it? 20 volts. There's also another circle that this will allow you to find watts if you need to. So it's going to be kind of the same circle. The letters are going to be different. AV instead of an O, it's going to be a W. Again, voltage is E, current is I, and then your power is going to be P, which is going to be watts. So watts equals amps times volts. Power equals current multiplied by voltage. So how much power is being used in a circuit when applied voltage is 13.8 volts and the current is 10 amps? That is a common power setting right there. So 13.8 volts and 10 amps usage. So we take A times V, and that's going to give us 138 watts. How much power is being used in a circuit when the applied voltage is 12 volts DC and the current is 2.5 amps? Again, we just plug it in there. And we're going to get 30 watts. How many amps are flowing in a circuit when the applied voltage is 12 volts and the load is 120 watts? So we're just going to divide those numbers and we'll get 10 amps. Okay, so what is the name for the flow of electrons in an electric circuit? In an electric circuit. I'll give you just a second here. It's going to be the current. Okay, what is the basic unit of electromotive force? Electromotive force is going to be the volt, the pressure of pushing in a circuit. What is the name for a current that flows only in one direction? It's going to be DC or direct current. Alternating current flows both directions. Direct current only flows in one direction. What is the basic unit of inductance? We're going to cover a little bit more of this in just a minute. That's going to be the Henry. Inductance is going to be the Henry. Which of the following might damage a multimeter? Letter C will get you every time. Attempting to measure the voltage when using the resistance setting, it will release the magic smoke. And if you have any questions, you can still put those into the chat, and we'll get that answered for you as best we can. So don't be intimidated by this picture here. What this is an electronic schematic, also known as a circuit diagram. You will oftentimes get these with a new radio that you buy. That way you can see what it's, how your radio works. The symbols represent electrical components. So each one of the little symbols on here, whether it's a circle with a line or a squiggly line or something like that, they all have a representation. The lines are like the roadways. We covered some of this last night. They're kind of like the roadways that connect the components together in order so they can function. So you will probably eventually start kind of getting your confidence together, and you might give soldering a try. There's two ways that you can solder things. There's the good solder joint where you actually get these surfaces that you're trying to solder. You get those hot enough, they make a good bond, good shiny smooth surface. There's no resistance added there. And then if you go and you try to solder, but the solder melts, but the actual surfaces you're trying to solder are not hot enough, you'll get this greeny, your dull color. We call that a cold solder joint. That can add resistance in your circuit. So I would suggest, if you want to do some soldering, start with something that you can practice on. Soldering is not hard. But it does take a little bit of practice to get it just right. And once you get it just right, you can usually remember that, and then you can make good clean solder joints. Okay, so a capacitor, it's basically a device that stores energy in an electrical field. The ability is to do this is called capacitance. And the way that it works, this capacitor in this demonstration right here is a flat capacitor. It's going to have a conductor, goes through the center of it, or connected to the center of it. It's going to have some conductive plates, going to have a dielectric insulator in between the two plates, and it's used to, and what it does is it takes energy coming in and it stores that energy until needed, and then it can release it either slowly or it can release it quickly. It kind of does, you can think of it kind of as it works similar to a battery. You can sometimes you can use these to function as a battery. You store that energy in there, and then you can discharge it. The basic unit of capacitance is the farad. On a schematic, this is what you will see down here on the bottom. This is a fixed capacitor. Well, both of these signals right here, or these symbols, are a capacitor on a schematic. The one on the bottom right there, that is a variable capacitor, so you can change the capacitance that the capacitor has. It has the ability to change. So the left one here is the fixed capacitor, and then we have the variable capacitor with that arrow there. An inductor, it works similar to, or its function is similar to a capacitor, except that it also stores energy, but it stores it in a magnetic field. So radio frequency is an electromagnetic property, and so sometimes we have to use not only capacitors but also inductors to get the result we're looking for, because it stores it in a magnetic field. This is called inductance. It's usually a coil of wire. That's generally what you will find in an inductor. So if you look at a circuit board, it's not uncommon to find just a little coil of wire called an inductor. It is also it its basic unit of is going to be the Henry also. So looking at the symbols down here in the bottom, that's going to be an air core conductor. That's just a standard, just a coil. Just there's nothing special about it. It's just a coil of wire. A variable inductor basically has the ability to. It's going to be a coil of wire, but it also has the ability to basically tap into one of these coils at a certain point and change its value. And then an iron core conductor is just another type of of coil inductor also. So a transformer is going to be, let me go back one. This iron core inductor right here is going to be commonly used in a transformer. So what it does is this allows a device to share or two circuits to share the magnetic field, used to transfer energy from one circuit to another, but they are not directly connected. So it's a magnetic. The magnetic energy there is being shared between those two, and they're not actually touching. It changes the ratio of voltage and the current. These are commonly used to change 120 volt AC house current into a lower voltage, or into a higher voltage. So if you have some sort of a power supply, you can oftentimes find these transformers in there, and it basically takes a power, and either, depending on how many turns the coil has, either raises the voltage or lowers it. Outside on your power pole, these are what you will find in there. It takes 10,000 volts and steps it down to 240 or 120. So it's just a way of changing voltage. We also have resistors. This is a component that is used to oppose the flow of current in a DC circuit. It's measured in resistance, and then the basic resistance is the ohm. There also is variable resistors. It's known as a potentiometer. A potentiometer is nothing but a variable resistance, and you will usually find these as volume controls in a radio, in your car, on a handheld radio, or on your new radio whenever you get one of those. So you have your fixed resistor and you have your variable resistor. We also have transistors. Transistor is a semiconductor device that is typically used to amplify a signal or as a switch. Radios have these built in. These are very, very common things. So in the one on the left, the bipolar transistor, you have your base, and then your collector and emitter, and your the little arrow right there shows you the flow of electricity. The one on the right is a field effect transistor. You have the electricity coming in, and then it kind of acts as a switch to control the flow of electrons in whichever way it needs to go. Gain is the measure of how well a transistor can amplify. So we're going to talk about gain a little bit more pretty soon, but in a radio, such as like a little handheld radio, you do have some what we call finals in there. They're basically transistors. The radio sends RF energy to that, and it amplifies it to a higher power. So that's one of the things that it's commonly used for, is amplifying, and then also within the circuit body, it's going to be act as a switch. A diode, think of this as an electronic check valve. It's a component that allows current to flow only in one direction. So if you have this and you stay within the boundaries of, or the ratings of what the diode says it's rated for, it will allow electricity to only flow in one direction. The diode symbol will show you which direction. So in this case, if you look at this, the arrow is pointing at the cathode, And so in this one, the electricity would come in, and this is showing you that which direction you need to install that if you need to install a new one. If you install it backwards, it's going to cut all your power, because it is, like I said, it's a check valve. It will not allow you to go backwards on your electricity flow. It also has an anode, cathode, and then you find that the flow basically on using that stripe right there. That'll tell you which way to go. LEDs, or light emitting diodes, emit light when it's forward biased, hooked up so it allows the current flow. It is also it is a I'm going to blink here. It is a diode that when connected properly, it actually will give out light. They're commonly used in visual indicators, lights, flashlights now, because they are so energy efficient. But they are also a check valve, electrical check valve. So as long as it is connected properly, and energy goes through it, it will release light as one of its outputs. So we're going to talk about resonant and tuned circuits. You will find these are used in some filters. This is a simple filter right here. Capacitors and inductors connected together can create a tuned circuit. So if C or L are adjustable, the resonant frequency can be varied or tuned. So it's basically, you have your inductors right here and your capacitors. You will also find these used in AC to DC circuits, because it will strip out that extra half of that sine wave, and you can make a DC circuit using a tuned circuit. Some power sources. Batteries are going to use chemical reactions to provide portable source of electrical power. There are many different kinds out there: lead acid, nickel cadmium or NiCad, nickel metal hydride, or lithium ion, or those are going to be the rechargeable types. And then the non-rechargeable are going to be alkaline and carbon zinc. Don't try to charge those, because it could cause those batteries to explode. But this symbol right here is what you're going to see on a schematic, and there's a good chance that you maybe ask what that symbol is on your test. So you'll want to familiarize yourself with that symbol right there. We're going to talk about switches. Switches, basically a device that interrupts or connects an electrical circuit. And it's basically just the pole makes contact, and it allows the current to flow. If you have that open, then no power can pass through that. There are different kinds of switches. You got the single pole, single throw. The one down underneath that is going to be a double pole, single throw. Then you have the top right is going to be the single pole, double throw, and then double pole, double throw. So those are just a few different types of switches. Basically, which you can tell what it is, because it'll have at least two little circles and a line that makes it look like it should connect to make things work. A relay is a switch activated by current in a coil by electromagnetic. They do the same thing. They use switches. Usually it's remotely controlled somehow, whether that's, say in your car, it's a relay in your car. They use the same pole throw names as switches. The moving switch is called the armature right there. That's the thing that will be connected to whatever it is that needs to be moved in order to make a connection. Contacts are named by when they are connected. So NC, this one right here, normally closed or normally open. Normally closed, if it is without power being applied to it. If it provides a normally closed circuit, then it's going to be norm closed. Otherwise, if it takes power to close the circuit, then that's considered normally open. The decibel is a ratio of two power values. It's computed by using logarithms. A positive decibel value indicates a ratio greater than 1. A negative decibel value indicates a ratio of less than 1. 0 decibels indicates a ratio of exactly 1. You will most commonly see this in when you're looking up antenna information. So if you look at this, over here is decibels. This is your power rating. So we're going to start a rating of 0. It's going to be a power ratio of 1. Well, every 3 decibels is a double in power. So 3 decibels is going to be a double of power. That's going to be 2. 6 decibels, that's going to be another double. So 2 to 4, another double. It's going to be 4 to 8, all the way down, 10, all the way to 100. So this is this you'll want to kind of try and memorize this. This is you might be asked about this. Usually not negative. It will usually be something along these positives. Just remember, every 3 decibels is considered a double. This is not a 3, but you can see there 0, 3, 6, 9, 10, 20, 1, 2, 3, 4, or 1, 2, 4, 8, 10, 1. Usually you will be asked one of these 2 bottom numbers right there. Not always, but that's what I've seen as a common thing. A little review. What electrical parameter is controlled by a potentiometer? Potentiometer is also known as a variable resistor, and the answer is going to be B, resistance. What electrical component is usually composed of a coil of wire? It's going to be D. It's going to be an inductor, and you will see coils of wire inside of a circuit if you pull the cover off of a piece of electronic equipment. Which of these components can be used as an electronic switch or amplifier? It's going to be a transistor. They can either act as a switch or an amplifier. What do symbols on an electric circuit schematic diagram represent? What do the symbols in a schematic represent? It's going to be the actual electronic components. It's not going to be logic states or anything like that. It's just showing you the physical parts and pieces of the actual diagram itself, or of the circuit itself. So looking at this diagram, what is figure 4 right here, if you can see that? That is going to be the battery. That's going to be your power source. Looking at component 9 in T2, which is right here. What is that component? Component 9 in T2, what is that? That is going to be a variable resistor, also known as a potentiometer. What are the names of the 2 electrodes of a diode? Talking about a diode here. It's going to be an anode and cathode. Gate and base is part of a transistor, so that one's out. So anode and cathode will be the ones that you want to look for. What component is commonly used to change 120 volts AC house current into a lower AC voltage for other uses? It's going to be a transformer. Also, the one that's hanging on your power pole outside, or the power brick that's plugged into your wall, powering something. Which of the following is used together with an inductor to make a tuned circuit? It's going to be a capacitor. Inductors and capacitors generally, where you find one, sometimes, oftentimes you might find the other. What is the characteristic appearance of a cold solder joint? It's going to be a cold solder joint. So this is going to be grainy or dull surface. It's not going to be nice and shiny. It will make a good contact, but it's not going to be pretty. What is the approximate amount of change measured in decibels of a power increase from 20 watts to 200 watts? Ten dB, 10 decibels. Okay. Questions. Take a second to do a couple questions. Take a short break here. I'm going to grab some water and take probably about 5 minutes, and then we'll pick back up in just a couple minutes.
Cool, that works. Let's switch over here. There we go. Okay, so I got you off the screen for a moment, Chris, so take your time there. Good. You guys, if you guys are enjoying this, hit the thumbs up like button for me on the video if you don't mind. It does help with the YouTube stats. There was a question earlier I wanted to address. Someone, okay, people were asking about the book. I did link the book in the chat just now, but the book is also linked in the YouTube description. If you look right below the video and you click on the link that says read more or expand or show more, it says. There's a bunch of links in there. Material will follow this book. It gives the Hearst Amateur Radio Club's website. You can check them out, and a few other links down there. So the book is down there. We are using the Gordon West W5YI book. But the question pool is the same in all the books. It just might go in a different order, which is not going to be any kind of big deal. It's just it might be a little bit different. But the question pool is all the same. So if you just want to study the questions, any of the books will work. Somebody asked, are these slides going to be posted somewhere, Chris? Do you guys have this uploaded somewhere?
What I'll do is I can put them, convert them to a PDF and put them on the club website. I'll link them on there because I mean, this is a good resource, and we have released them under a Creative Commons license, so anybody can use them. All we ask is that you give attribution.
Yeah. Okay, good deal. I wasn't sure what I was going to let you make that decision. It didn't matter to me, but yeah, it's really, I guess it's kind of Mike's decision, but yeah, good deal. So w5hrc.org. Once Chris does the conversion to PDF, they should be available there. So again, that link is in the YouTube description of this episode and all the other episodes also. So you can always come back to these on YouTube and find the link to the Hearst Amateur Radio Club website. So, Carrie's in the chat now.
Yeah, this break came at the right time. Our lawn guys are here.
Oh,
and our dogs are going crazy.
Oh, see, I don't even hear that. I hear the kids scream every now and then, but I don't hear any dogs. So, but there's so many dogs barking in the background of so many of my videos. Maybe I just tune it out.
Yeah, Eli, he has one volume. He's 16, 17 months old. He has one volume, and that is 100% all the time.
Yeah. Brad Hall asks, will the general class be offered online? Frank, did you answer that? No, you haven't posted that. The general class, I've said this before, and it's okay, people come and go into the stream. The general class is posted and has been posted on my channel since November. Same club, same instructors give the general class. I recorded it last fall and posted it up there. It's in a playlist of 6 different videos on this channel. Frank can post that link in here in just a second in the chat. You guys can go watch the general class as soon as you can go watch it right now. As soon as you're done with your tech or do it all at the same time, however you choose to do that. We've talked about possibly live streaming a general class in about a month or so. Nothing's been decided on that yet. Be sure to sign up on my email list, and we will make the announcement there, also on social media if we do that. But But like I said, the general class is already there. The question pool won't change on the general class for another couple of years. So the material, if we do live stream the general class in a month, it'll be the exact same material that's already posted on the website. So nothing's changed. Or I'm sorry, on my channel, nothing's changed. There you go. Frank just posted the link to the playlist. I think he's asking if the actual general test is online. Yes, you can test all 3 levels online at the 2 links that I know Frank shared those earlier too. You can go to hamstudy.org/sessions and find several places online or sign up online to do testing for technician, general, and extra. And you can also go to the Anchorage VEC website, which is like kl7aa.org, I think, and you can find online testing there as well. Anchorage does it with a proctoring system, so you need to have another person in the room with you when you test. That is an official proctor. It'll give you instructions on their website who can sign up and apply to be a proctor. And then, but the hamstudy.org guys are just doing all online. So they've got some limited capabilities right now, but they are expanding. And you can go out to Frank just posted those links in the chat. So Brad Hall, can you upgrade to general online? Yes, those 2 links that Frank just posted in the chat, you can go out there and check out general class or extra class upgrades on those links. So, okay.
All right, all is quiet, so we are good to go whenever you're ready.
If you're ready, go ahead.
Okay. You pop this back up here.
There we go.
Okay. All right, so basically, we're going to talk about some antennas and feed lines. This is my favorite subject in amateur radio. I love antennas and things like that. So antennas are going to come in 2 varieties. And depending on what the electrical field is, will determine the polarization of your antenna. The easy way to think about this is if you have an antenna, you want to make sure your receiving antenna is also exactly the same. You know, if it's going to be up and down, that's what you need. If your antenna is going to be like this, it's going to be horizontal. You're going to have a lot of difficulty in talking to somebody, even very close. You're going to have a lot of difficulty talking to somebody with an antenna that's horizontal if yours is going to be vertical if yours is going to be horizontal, and then also the same way around. You want your antennas to be exactly matching, horizontal or vertically polarized, and then vertically polarized, horizontally and horizontally. So just keep your antennas oriented the same direction, and you will have success. I don't want to get too deep into the polarization because last time we did this, we ended up going well down down the hill that it took a lot of time, and we ended up coming to the same conclusions. And so what you need to know, just like I said, keep your antennas the same. Don't have one like this, because all of your energy will be all of your RF energy will be going away from the actual antenna that you want to talk to. Let me go back one more thing. So if you're watching TV and you see I don't know if you can see my video here. When you see people talking with their antenna down like this, and they're in a car or something like that, they're not actually talking to anybody, because your radio was not designed to operate not only upside down but sideways. So one type, the most common type of antenna really is it's called the dipole. It's made from electrically conductive material, either preferably copper, or you can use aluminum and a wire, a rod, a tube, something that is able to radiate. It's electrically 1/2 wavelength long. So if you look at a dipole, you're able to, if you can make that determination of how long it is, you can usually find out what band that antenna is designed for. So looking at this chart here, this is basically a simple dipole right here. Here's your center conductor. This is where your coax will go from right here in the very center, go into your radio. This one, this arm right here is going to be 1/4 wavelength. This arm over here is going to be 1/4 wavelength. Combine those together, that's going to be 1/2 wavelength long. So let's just say this is a 6-meter antenna. If this is a 6-meter dipole right here, here's your center conductor. This is going to be 1/4 wavelength, 1/4 wavelength. The overall wavelength is 1/2. So if you take 6 meters and you cut that in half, you basically have a 3-meter long antenna to operate on a 6-meter rate frequency. The way you calculate this is this little number right here. You're just going to have to memorize this, and it'll be something that hopefully you will use throughout your ham career. 1/2 wavelength is calculated by taking the number 468 and then dividing the frequency that you want to operate on. That will give you exactly how long your antenna needs to be from the center, or how far it needs to go out from the center point on each side. I've built dipoles before. It's really, really easy to do. I did it for 20 meters, and the antenna was about 10 meters long, about 30 feet total, 16 feet in each direction. So it's your antennas can get large, and they can get large very quickly once you start getting more and more involved with like 20 meters or 40 or even 80. Those antennas are very large. You also have vertical antennas. These are more common on VHF, UHF, but you can also find vertical antennas on HF too. Like I said, a vertical antenna, it's going to be a 1/4 of the wavelength. So if you look at this, it's in a way it is kind of like a dipole. You have 1/4 wavelength antenna. The ground is going to act as your other half of that antenna. So you usually have to have a good ground, because that's going to be the other half of your antenna. Even better is to not only have your vertical antenna, but you can go into a plate and have wires strung out from that plate. So, but this is a vertical antenna. It's made also from a conductive material such as copper. Sometimes they're made out of fiberglass with a copper wire in it. It is electrically 1/4 wavelength long. So it's essentially half of a dipole. So it's 1/4 wavelength long, and the feed line is usually connected at the bottom. The way that you calculate up here, the way you calculate a vertical antenna is you're going to take that 468 number, you're going to cut that in half. So now you're at 234. So 234 divided by the frequency is going to give you how long your antenna needs to be for the frequency that you're on. So 234 divided by the frequency gives you the 1/4 wavelength. So for line of sight and ground wave propagation, it's important that the antennas on both ends of the communication path have the same polarization. We talked about this a minute ago. If your antenna is like this, you want the other antenna. If it's like this, you want it to be like that. Vertical to vertical, horizontal to horizontal. For skywave, where you actually send that signal up to the ionosphere, it doesn't make much of a difference because the polarization is randomized. When it gets up there, instead of it being perfectly horizontal, it can be any polarization possible. I mean, because it gets randomized out there. I've never generally had a problem with a horizontal antenna receiving somebody who's transmitting on a vertical polarized antenna over skywave before. These little flexible rubber duck antennas they're convenient, but they do not transmit or receive effectively as a quarter wave antenna. Your radio that you get, your first radio, will come with just a standard issue antenna. There's nothing at all special about them. Generally, the first thing that you want to do is replace that antenna with something third party or aftermarket. Your antenna is going to essentially be the most important part of your setup. If you have a poorly functioning or poorly performing antenna, your signal is going to be transmitted very poorly. You may have a lot of loss. So, like it says, they don't transmit or receive effectively as an actual quarter wave antenna. If you try to use your handheld inside of a vehicle, usually the roll cages built into them basically act as a shield, and very little signal will actually get out. So you want to have some sort of an antenna outside in order to help with your transceiving. So there's different kinds of antennas. We have an omnidirectional antenna, similar to a light bulb. When you turn it on, the light goes in all directions, up, down, out to the sides. And that's how an omnidirectional antenna basically radiates. It's going to radiate in all directions. We also have directional antennas. They do what they do is they focus that light into basically like a beam. Think of a satellite dish. If you use a satellite dish, that is designed to focus your RF in one direction. That way, instead of your energy being dispersed in all directions, it's now being focused in one direction. You usually can get better reception and transmit in one direction a lot farther. The ability to focus more RF in one direction is called gain. So antennas, almost all antennas commercially made they have a gain rating, and it will usually say it on there. So this is a directional antenna compared to an omnidirectional antenna. These are also some more directional antennas. We have a quad antenna. Those are usually very large in size. The middle one on the bottom, that's a Yagi antenna. And then we have the dish. Every one of those is designed to focus that energy in one direction. That way, that it's not all going in every direction. You will usually hear directional antennas, Yagis, quads, a dish. You will often call those called beam antennas. You'll hear that all the time. That's a beam. Just bought a new beam antenna. And this is what they're talking about, a directional focusing antenna. The radiating elements of antennas are generally built from metals that are good conductors but don't rust: copper, aluminum. Then the hardware to assemble it, you want to make sure that you use something like stainless steel that doesn't corrode, because the last thing that you want is to have a tower with an antenna up on top of it. The conductors are in great shape, but the hardware is rusting and eventually just corrodes and your antenna falls. So you want to pay a little bit more money, get the stainless steel, because in the long run it does pay off dividends. That way you don't have to climb up there every couple of years and replace out hardware. To feed your antenna between your radio and your antenna, you're going to use some coax cable generally. The most commonly used is this 50 ohm coax right here. It has the advantage of being easy to use, requires few special insulation requirements, doesn't take you can put an end on there using something like just a knife, and it's got this simple layout right here. You have your center conductor. That's generally where the actual RF energy is flowing. Then you have a dielectric insulator, and then some sort of a metallic shield. Higher end cables will have copper, or maybe even aluminum. There's some very good cable out there that's got aluminum, and not only does it have aluminum, it's like a foil, but it also has aluminum braid, and then the outer insulation. Um, the outer insulation does nothing but just keep rain and everything out. The metallic shield is a shield. It helps get rid of outside interference sources. So the lowest loss fee line for VHF and UHF has been an air insulator. So that dielectric right there would be replaced with basically air. It's very rigid. It's not something that you would install at your house because it is a very rigid. It's called hardline. Hardline is something that you will usually install at a repeater site that has a long run because it has a very low loss. Um, and I think we have a picture of some hardline, but it works exactly the same as the smaller cable here. Black color of the outer insulation provides protection from ultraviolet damage for sunlight. Now, after a few years, just getting pounded by the sun, your coax will get old. The inner part of it will probably be just fine, but the outer may crack or get damaged somehow from critters or whatever. Um, if water gets into your coax, that is the death knell of coax. Water will destroy your coax. You basically have to cut out any part that has been exposed to water because that is no longer any good. So you want to make sure you get all your connectors sealed up good and tight. You don't want water in there. Otherwise, you'll end up having to replace your coax very quickly. When you start getting a higher because they're measured in ohms, 50 ohm cable. When you start getting damage and things happen to it, that impedance will start to increase, and eventually, as you're using it, your coax will begin to absorb that RF energy, just because of the electrical components, and it'll start to convert that RF energy into heat. So you're even if you're just transmitting 50 watts into a damaged cable, you can start experiencing a hot coax cable just because of either age or damage. The most common cause for coax failure, like I said, is moisture contamination. The air core, or the hard line that we talked about just a minute ago, is extremely susceptible to water damage. So whenever you put that up there, because it's usually a very heavy cable, um, whenever you get your coax connectors, it's generally taped. It generally has some self-sealing tape, some sort of a tar, and then another layer of tape, and then um, like a foil outer part. I mean, it's very well sealed because it's very good, but very good cable. But at the same time, you have to make sure to get that sealed up very well because you don't want that stuff starts at about $1 a foot. So if you have a 200-foot run of hard line, I mean, it's not uncommon to see $5 a foot. So it can add up very quickly if you don't get everything sealed up nice and tight to keep water out. So when you set things up, you want to make sure that you stay consistent with your coax. That's really the best way to do it. And the reason is, we'll give this plumbing example right here. As long as your pipe is all the same size, the water going in this pipe will just continue to flow. It doesn't have any problems. There's no restrictions or anything like that. So when the source and the load are matched in size, you'll get the maximum flow. When you do, say you go from a larger piece of coax down to a smaller one, and this will generally be at higher power. If you change coax sizes or go into something that's more maybe not quite as optimized for, say, 50 ohm, and you send power through it, you will probably get some restriction there, some higher impedance, which is higher ohms, and you could get essentially back pressure. What it is, it's you get energy coming back to your radio. That happens when the load is not matched to the source, and the flow will be reduced. So as I said, resistance is the opposition to electricity flowing through a conductor. That's basically just a restriction in flow. Resistance is measured in ohms, whereas in RF, impedance is what we call impedance is the opposition to RF energy. So resistance is electrical. Impedance is what we talk about regarding RF energy flowing through a conductor. Same thing, different medium. Impedance is also measured in ohms. However, it can change with the frequency, and it does change with the frequency. So there's different different aspects that you have to look at whenever you're setting up an antenna and running your feed line, just to make sure that everything is optimal that it can be. And oftentimes, hams in your area love to have what we call antenna parties, where they will usually be happy to come and help you get things set up and teach you, Elmer you into how things should be done. When the antenna is properly matched to the transmitter, you will get the maximum forward power and the maximum RF radiation from the antenna. So your radio will be transmitting, it will be sending energy out at 50 ohms through a 50 ohm coax cable, hopefully into a 50 ohm antenna tuned for the frequency that you want. That would be basically a kind of a perfect setup right there. If you transmit 50 ohms into a say a 95 ohm antenna, well, because that is not matched properly, you're going to get some RF energy reflected back to your radio. That power loss is converted to heat in the feed line, and if there's enough of it coming back, because the antenna is either poorly made or it's so out of tune for the frequency that you're trying to operate on, it does have the potential to damage your radio. So you don't want to use an antenna that's made for 2 meters. You don't want to use that on, say, 10 or 12 meters, because you are probably going to get a lot of reflected power back, and your newer radios will detect this and kind of automatically scale themselves back to protect themselves, because they can recognize that energy coming back. The way that we measure that the effectiveness of the antenna itself is using what we call standing wave ratio. It's your SWR. It's expressed as a ratio of the forward power compared to the reflected power in the antenna system. And it just basically tells you how much power am I transmitting, or how much am I sending, and then how much of it is actually coming back. This is one way to visualize that. So a 1.0 to 1, that is considered perfect. There is no actual perfect antenna, because there's no perfect feed line. There's always something. Now you can have a 1.1, which is that's great, but essentially there's not really a 1.0 antenna out there. There's some close, but not always. Looking down at this, if you start getting a 2 to 1, and you can use an actual meter to determine this. So you're going to send 5 watts out in a 2.1, or excuse me, a 2.0. 5 watts out. The 4.45 is actually transmitted. The rest of it is coming back. That's about an 11% power loss. That's a 2 to 1 SWR reading. A 3 to 1 is even more. Eventually, a 10 to 1. Anything above 6 is dangerous to your radio. Anything above 3 makes me nervous about using. I wouldn't use anything above 3, just for the sake of my radio. But anything 2 and under, that's usually a pretty good match. So most modern transmitters will begin to reduce power automatically, especially in HF. They will scale themselves back automatically when it starts getting above 2 to 1. That way, um, they don't effectively fry their amplifier transistors, or finals as we call them. Can cause your radio to overheat and fail if you just continue to use an antenna like that. So how can you tell? What is the instrument that you use to determine if your transmitter feed line and antenna are properly matched? There's two kinds, two types of meters. So you can get a directional watt meter. You put that in line between your radio and your antenna, and then that will tell you how much power is going one way. Then you flip that switch, and it will tell you how much is coming back. Then you do the math, and you can figure out what your SWR is. So your directional watt meter is more of a manual mode. And as it says, you switch it one way, it measures the power going to the antenna, switch it back, and it measures coming back. So that's a directional watt meter. You will see more commonly used an SWR meter. This is measured, it will measure that exact same thing, but then it will actually give you your SWR reading automatically, and you don't have to do that calculation. It will display that ratio automatically between the forward and reflected power. Call that the SWR meter, and that's the main difference. So you have your directional watt meter, that's your manual mode, and then your SWR meter does everything for you. If you see an erratic movement on your SWR meter, you may have a loose connection somewhere. Check your connections, because even if you have a mismatched antenna to your radio, your SWR will maintain whatever the level is. If it's a 6, it will maintain a 6. If it's a 5, it will maintain. If you see it swaying back and forth, you have a loose connection somewhere. So you'll just have to check your feed line and make sure everything is connected solid. An antenna tuner, that's kind of a deceptive name. An antenna tuner, what it does is it will take the output of your radio in 50 ohms, and using conductors and inductors inside this little box, it will allow you to, I don't want to say tune, that's what it says, but it will allow you to take that 50 ohms, convert it to 95 ohms in this picture, and essentially trick the transmitter is basically what it does. It's called a transmatch. And so with the combination of the inductors and the capacitors and moving those knobs around, you can make your radio think that is a perfect antenna. If you're transmitting out at 50 ohms into a 95 ohm repeater, or into a 95 ohm antenna, you're still not getting all that energy out. You're still having that loss, but this tricks your transmitter to think it's perfect, so it will transmit that full load. And then essentially the anything that's reflected back, that antenna tuner kind of stands in the way of your radio itself. So it's a poor, I don't like the name antenna tuner, because it kind of says something that it doesn't really do, but it matches the transmitter's impedance to whatever your antenna impedance is. It's called a transmatch. We also have dummy antennas, more commonly called a dummy load. It simulates an antenna. Usually what it is, it's some sort of a bundle of resistors all combined together to basically take that RF energy and turn it from RF energy into heat. That usually would be, if you're going to have a 1.0 antenna, that would generally be what it is, because they're designed for multiple frequencies, and so you put that energy in, and it completely turns it to heat. You'll get a little bit of transmit, but it's It's designed for testing. That's all it's used for testing for. If I hook a radio up to a dummy load, your range will be cut down to just within your yard sometimes, and so they're generally they can either be little sockets that go onto the back of your radio, or if you're going to be transmitting a lot, they may require larger. Uh, you can get some that look like they come in paint cans, and you fill it with mineral oil, but it's basically just a group of resistors in some sort of an oil or something to basically change it to heat. So it's like a heat sink, basically. It's going to take all that RF and turn it into heat. Review. So what is the primary purpose of a dummy load? It's going to be A, to prevent the radiation of signals when making tests. You still have to identify when using them, but just in case there is some RF energy getting out there. But basically, it's to kill off the RF from going out far. What is a beam antenna? Beam antenna is going to be an antenna that concentrates signals in one direction. What is a good reason not to use a rubber duck antenna inside of your car? This is what we call a rubber duck right here. The signals can be significantly weaker than when it's used outside of the vehicle. Because of the structure of the car, you'll get all that energy is reflected inside of your car, and very little will get out. Why is coax cable used more often than any other feed line for amateur radio use? It's because it's easy to use. Doesn't require very many special tools. If you need to put in a connector on, you can use a razor blade to cut the insulation off and get it prepared, and then just solder on or crimp on. So there's not a whole lot of special tools required compared to some of the other types of feed lines. Which of the following is the most common cause of failure in coax cables? Unfortunately, it is very common, and it's moisture contamination. What is a disadvantage of air core coax cable when compared to foam or solid dielectric type? So it requires special techniques to prevent water absorption, and it's often a very expensive cable, and so to keep it watertight, it requires some very special techniques to make sure that no water is going to get in there, because you definitely don't want it to destroy hardline, because it's very, very expensive. What does an antenna tuner do? It matches the antenna system impedance to the transceiver's output impedance. It tricks the transmitter, is essentially what it does, to thinking that it has a perfect antenna. What instrument other than an SWR meter could you use to determine if a feed line and antenna are properly matched? I'm going to use a directional watt meter. There is an advantage to using a directional watt meter. Directional watt meter usually are calibrated instruments that will give you a more precise reading, where an SWR meters are very good, but because they are doing all the comparison and everything for you, it's going to be pretty accurate, but it's not going to be quite as accurate as an actual directional watt meter. Questions can be placed into the chat, and we're happy to discuss them. We're going to continue on here. We're making pretty good time. We're going to talk about some electrical safety. So what this kid right here is doing we've probably all done it before. I have stuck things into a electrical socket before. Don't do that. Just don't do it. It will bite you. Sometimes it will bite you worse than others. So voltage as low as 30 volts can cause a dangerous electrical shock. I've heard some say that you may not even feel voltage as low as at 30 volts. You may not even feel that, but it's still dangerous. The current does the real damage. However, you're at 30 volts. That can cause an electrical burn, but it's the current that does the real damage. That's not saying the voltage doesn't do damage, but the current is what will really get you. So current as low as 100 milliamps, 1/10 of an amp can be fatal going across your heart. It can cause your heart to stop. A little saying here: it's the volts that jolts, but it's the mills that kills. That's pretty accurate, pretty clever right there. So just you always want to be very careful when working around electricity. This is a typical electrical connection right here. Black is hot, white is neutral, green is ground. A way that you can remember green is ground is grass is green and it grows in the ground. Oh, gee. So the thing here that you want to make sure that you memorize is green is going to be ground. So grass is green and it grows in the ground. So some protections that are out there, the fuses. We probably all run into fuses before. The purpose of a fuse is to limit the amount of current that flows through a circuit. Never install a larger value fuse than recommended because it could cause the wiring to catch fire. They are there for your safety. Because if it pops, if the only reason a fuse will pop is because there is something wrong in the circuit, whether it's too much power is coming through, or too much amperage, or a short circuit. That's the only reason that they are designed to pop is because there's something wrong with whatever it is that you're doing. And so if you install a larger value because the smaller ones keep popping, you're taking the chance of your power wire, whether that's say from a radio or something in your house. You're taking a chance of that catching on fire because more energy is going through than is designed and what the cables can handle. When erecting an antenna, keep well away from overhead power lines. A lot of jurisdictions, a lot of cities will have some sort of rule that says you have to have enough clearance between power poles and your house to where if that antenna falls over, it's not going to touch the wires. That's a really good thing to keep in mind. You always want to make sure that you are clear of electrical lines because all it takes is just one little touch and will game over. So when erecting antenna, keep well away from the overhead power lines. Never run any feed lines or wires under or over the power lines. Not only is this dangerous, but you will get just incredible interference noise on your signals. So you want to stay away from those as much as you can. Grounding is very important. It's part of the electrical plan that we have. Ground all of your equipment to a common point outside to reduce the risk of electrical shock in the case of component failure. So in this little example right here, if you're going to be setting up a tower, you want to ground your antenna structure to minimize the risk of damage from a lightning strike. So in this example right here, you have that tower base that goes down into the ground. Each one of those legs, and this is a good setup, each one of those legs has its own grounding rod attached to it. And then all of those are attached to each other. The main point of grounding, a good ground, is to keep the electricity, the lightning strike energy out of your house. That is the whole reason that you do grounding, is because you want to make sure that none of that lightning comes into your house, that it's all dissipated into the ground. You can use a flat strap, or a 10 gauge or heavier ground wire to come inside. But if you have more grounding rods than that, that is okay. You generally don't want to connect your radio equipment to your house ground, just because that if something were to happen to one of your radios, you could actually use your electrical system in your houses. It would energize with the RF energy and could possibly damage. So make sure you have a good ground. I generally try to isolate my RF equipment from my house. That way there's no crossover there. All right, some tower safety. It's always exciting to have a new tower raised. Some of the rules that you want to live by: never work alone. Always have a helper. You never want to work alone. You don't want to climb up there on the top and then, Lord, something happens and you have a heart attack or whatever. Something happens up there. You're up there and nobody knows that you're up there. So always have a helper. Stay off the tower when there are storms or lightning anywhere in the area. You don't want to be on the receiving end of a lightning bolt. Stay off the tower during high winds. You don't want to fall off that thing because it's a long way down. Always use safety equipment: hard hats, safety belts, safety glasses. If you have one of the tower that has the ability to crank up, you want to make sure that it is completely lowered, because you don't want to be climbing a crank up tower and you hit a safety lock of some sort and that thing starts sliding down. Not only are you on top of it, but if your feet are on the rungs, which they would be as you're climbing, your feet will be cut in half. So if you have a crank up tower, make sure it's lowered. That is the safest way to do that. But always have a helper. Never work alone. That way that's one of the most important. That way you always have that spotter. So what is right here? Let's if you can see this picture, here's the tower building crew. They're getting ready. What's right in this picture? They're hard at work in the right one. They're getting ready in the left one. They all have hard hats. And then when they're actually doing the work, they have no hard hats. And then there's they do have their people, multiple people there, but you want to work safely. If you look up here, what is this? What do we call that? Anybody have any idea? We call that a gin pole. What that does is that allows you to connect. That allows you to connect to the top, the highest point on your new tower that you're assembling, and it extends up above the tower, and it has basically has a rope that you will lower down. Whoever's on the ground will tie the tower section to it, and then they can lift that up and allow you to lift it, put it on there. You can tighten it down, get it clamped down, and installed properly. Then you undo the clamp, you raise it to the next one. So it's a way to step up as you're assembling a tower. A gin pole clamps to the leg of a tower and allows you to lift more antennas or more tower sections. Those are not uncommon to be, or those are commonly used, while installing an antenna. Some battery safety. Hams often use lead acid storage batteries for backup power. There's some things you need to be aware of. They do have caustic acid. They do have, I believe it's sulfuric acid in there. When you charge them, especially if you charge them quickly, they do emit explosive gas. They emit hydrogen gas. And if you hook up some sort of a fast charger to them and you charge them too quickly, they can explode. And so you have to be aware of that. If you can have your batteries on some sort of, say, a trickle charger, some sort, where it charges it very, very slowly, and you can have it outside in some sort of a vented box. That's the safest thing. I'm always leery about putting one indoors, just because, not because I charge them quickly, but because they do emit hydrogen gas when they're charged. So you can charge your battery by using an AC powered charger, like just a standard battery charger. You can hook it to your car battery and run the engine for a while. That's another way that you can charge your batteries. So you always hear about some people that are worried about, say, using your cell phone and getting cancer in your ear because it's so close. RF energy is non-ionizing. It doesn't have the ability to destroy your cells at a molecular level. That's not what it is. It's not X-ray. It's not gamma rays. It's non-ionizing. What it will do is, if I'm using my little handheld right here and I've got it too close, it will cause heating of your skin, because your skin will it will absorb that RF energy, and it will heat. Some areas in your bodies respond differently to RF radiation at different frequencies. Your eyes are extremely susceptible to heating by RF. So whenever you're using your handheld radio, you want to try and kind of keep it away from your eyes. I mean, you don't want to have a radio right here next, even the antenna touching your head or anything. You want to kind of keep it away. Keep it 6 inches away. You'll be perfectly fine. Most susceptible at 30 megahertz and up. 30 to 300 megahertz. It actually, I would say, goes higher than that. But for this talk right here, we're going to say 30 to 300 megahertz. It depends on the frequency and the strength of the RF radiation and the time of exposure. We're going to cover time and exposure limits here in just a minute. But the higher the frequency, the more susceptible your body is to absorbing that and actually heating. Usually a low power cell phone or a handheld radio are not going to cause you issue unless that antenna is like right up on you. So some RF radiation, radio waves of electric and magnetic energy between 3 kilohertz and 300 gigahertz. That's the range here. 50 megahertz has the lowest maximal possible exposure. That's what MPE means, maximum permissible exposure. Excuse me. Between 30 and 3 megahertz, that's going to be your critical zone, critical for human exposure. When you see the FCC regulations, this is the range that they are generally talking about, between 30 and 300 megahertz. VHF and UHF radiation, like I said, is considered non-ionizing because it doesn't have the capability of altering molecular structure, but it can heat up. This can be demonstrated by your microwave. Your microwave uses high RF energy in close range with your food to heat up your food. It's again, it's not ionizing. It's not damaging the food. It's using RF energy to heat it. It's absorbing it. So the device in your microwave that generates that heat is called the magnetron. It's a very high-powered RF transmitter. Is basically what it is. Your microwave oven running on high power is considered a 100% duty cycle. So your duty cycle, we're going to take this 1 minute time period right here. If that is running at 100% duty or 100% power for that 1 minute, that is considered a 100% duty cycle. If your microwave is running on medium power, where it runs, it cuts off, it runs, it turns off, it runs, it turns off on 50%, that is considered a 50% duty cycle. half the time it's on, half the time it's off. So that is your duty cycle of your microwave. Your microwave is actually a very powerful, reliable piece of machinery. I mean, it can operate at 100% duty cycle for hours at times. So what you want to keep in mind is if it's running for a duration of whatever the duration of time is, in this case 1 minute, if it's running at 100%, that is considered a 100% duty cycle. If it's running at 50% of the time, that's a 50% duty cycle. Some of the factors that some factors that affect the resulting RF fields: frequency and power level of the RF field, antenna height and distance from the antenna to a person, and then the radiation power of the antenna. These are some of the factors that will affect the RF field that you will be creating. All stations running more than 50 watts of peak envelope power at the antenna on VHF 30 megahertz and above require an evaluation of RF exposure. So if you're going to frequently run at full power at a 50 watts, 100 watts, or whatever, you need to do some sort of an evaluation of RF exposure. You can do that yourself. You can use a RF field strength meter. You can do calculation based on some FCC paperwork or electrical system paperwork, or you can do the evaluation online to make sure that way you get the information you need and you can adjust your station in order to stay compliant. So 50 watts of PEP, peak envelope power at the antenna, 30 megahertz and above, require an evaluation of RF exposure. If you change your equipment or relocate antennas, you need to do it again. There are free resources out there I have used in the past to do that, and it basically just tells you put how much power you're going to be using, what kind of antenna, what the gain of the antenna is, how high the antenna is, and will there be people close to it. Hit submit, and it will say you need to make sure that you are at least 6 feet away from the antenna at whatever power is that you're going to be using. And you can print that out, stick it on your wall, and you're good to go. And I'll show you my field strength report once we're done with the actual class. So you can perform the RF exposure evaluation using any of the following methods. You can do it directly, direct measurement by calibrated instrument. That's going to be a field strength meter. You can use mathematical calculation based on the Office of Engineering and Technology Bulletin 65, or use a computer modeling calculation, easy to find on the internet. So some RF safety: if you and your family if you and your family at home, you are in a controlled environment. You are in control of that RF energy. You're aware of and can exercise control over exposure to RF energy when you're transmitting. Your controlled environment time limit for high power, if you're going to be too close to that antenna, is going to be about 6 minutes, because you're closer to that antenna than your neighbors. You're also in control of that, so you want to stay away. These are going to be your maximum permissible exposure. So that is assuming that you are right next to the antenna, receiving that energy. It's not just that's all I can talk on the radio. That's not what it is. It's talking about, this is the safety. If you're really close to the antenna, this is going to be your exposure limits. Your neighbors are in an uncontrolled environment. They have no idea that you're pumping RF energy into their house. The kid riding on the tricycle has no idea. The lady riding on the street has no idea. They have no knowledge, but they're also not right next to your antenna. But let's just say that they're close enough to where there could be concern. That's an uncontrolled environment. They don't have any idea. They don't have any kind of control over what you're doing. Their time of exposure needs to be limited to about 30 minutes. And again, I say that is if they are really close to the antenna, closer than you're having a barbecue outside or something like that, and you're pretty close to it. You want to limit that to 30 minutes of exposure time. So a review. Why is it unwise to install a 20 amp fuse in place of a 5 amp fuse? Because excessive current could cause a fire, and your wires they can start smoking and start shorting out. So you want to make sure you install the proper fuse into the circuit. Which of the following is an acceptable method to determine your station complies with FCC RF exposure regulations? This is one of those rare D. All of these choices are correct. You'll see these in your test. You will see them. Used to, it was if you saw this, it was a pretty good chance that all of these choices are correct. Was the correct one? Not so more. Not so much anymore. Don't rely on all of these choices. But in this case, it is all the choices are correct. Why do exposure limits vary with frequency? Because the human body absorbs more RF energy at some frequencies than another. Generally, the higher the frequency you go, the more absorption your body is likely to experience. Which of the following is an important safety rule to remember when using a crank-up tower? Please make sure that it is fully retracted in down position before you start climbing. That way you don't take that chance of it accidentally falling down and taking your feet with it. What is considered to be a proper grounding method for a tower? It's going to be separate 8-foot long ground rods for each tower leg bonded to the tower and each other. So a ground rod to the tower, this ground rod to this leg, and then this one, and then all of them connected to each other. Which of these precautions should be taken when installing devices for lightning protection in a coaxial cable feed line? Give it a couple seconds. That's some long answers there. It's going to be D. Ground all the protectors to a common plate, which is in turn connected to an external ground. You can buy plates that they have it's some SO239 connectors on it that you would come from your antenna, you would plug into that plate is connected to a ground rod, and on the other side of the plate you just connect. That way there is a grounding intercept in line with that cable itself. The whole point of grounding is to keep lightning energy out of your house. Questions or anything like that? We are actually done with the actual course. I'm going to give you some pointers about your test and what you can expect. So you've heard me say here's some of the things you expect. We're gonna compile all that, and I'm going to give you a few words, a few tips about what to expect. So preparing for your technician license examination, it's an exciting time. It can be nervous. The very first thing that you're going to get is it's going to be this form right here. This is called your 605 form. This is where you put your last name, first name, station call, your mailing address, all that information, email address, if you want to receive a notification email that your call sign has been assigned. Right here, I want to show you this. This is your federal registration number, your FRN number. If you don't have one, you can get one. They're free. You basically just set up an account with the FCC. If you don't have an FRN number, then you have to give your social security number. We would rather not have to handle your social security. That's just not. I mean, we handle all the paperwork safely, but it's just not a risk that we really would like to have. So if you could pre-register before you go to do your test and get that FRN number, write it down. That way That way you have it, and it might I don't know for sure, but it might speed up the process a little bit.
That question, Chris, was brought up in the chat yesterday while you were teaching about whether people were required to get an FRN number before taking the test. And it was basically like no, you're not required to do it, but if you go get an FRN number, then like Chris said, you don't have to put your social security number on a form, and some people are kind of scared to do that. You're going to be assigned an if you don't go get an FRN number prior to taking your amateur radio license test and passing it, they will assign you one when they assign you your call sign, and then that FRN number is yours forever. If you go get a GMRS license, they will assign you an FRN number. So then if you go get a GMRS license first and a ham license later, or vice versa, they're going to use the same FRN number for all of your licenses within the FCC ULS.
Must have a fly.
It's a dirt dauber, I think it is.
I have a fly buzzing around me.
I thought it was a wasp, but I think it's a dirt dauber. Go ahead, man. Sorry. Yeah, but the question of FRN was brought up yesterday. That's why I mentioned that.
So, I mean, you either have to give them an FRN or a social security number. One of the two. We'd rather not have your social is the main thing there. Have you ever been convicted of a felony? Yes or no? And then most of the information on here, your VEs will verify, but you're going to be taking examination for a new license grant. If there's ever anything that you're unsure of on this, you can always call one of your VEs over to say, I don't know what to do right here, and they're going to be happy to help you. Here's something about your VE compared to the way you used to have to go test. What is about 30 or 40 years ago, the FCC turned over ham examinations over to the to VEs, because you would go test, you would have to sit down, as Mike says, you'd have to sit down in front of an FCC examiner, for an actual examiner who was employed by there, who didn't want to be there. They didn't want you to be there. They didn't want you to take a test because you were interrupting their time. So it was all basically it was kind of a difficult situation, and hopefully you pass. Your VEs want you to pass. We want you to get your license. So we are actually there to help you. We're going to do whatever we can to help you, other than giving you the answers. That's the limitation there. We're not going to give you the answers, but we might help with whatever kind of information that you need, especially on the 605, because this used to be an FCC form, and you can tell by Form 605 used to be a government thing. You sign it and you date it and you stop. We take care of the rest. What to bring to your exam session? This is going to probably go for both online testing and in-person testing. You're going to need a couple of pencils. Bring a ballpoint pen to fill out your 605. You can have a calculator. You cannot have your phone. You cannot have a smartphone at all. That is against the rules. Testing exam fee. Some VEs charge $14. Some charge maybe a little more. And then they will stipulate whether cash or check or what it is. So 2 lead pencils for the actual test, a ballpoint pen, blue or black, to actually fill out the 605, calculator, and exam fees. Cannot have a cell phone, cannot have a smartphone, and you cannot use your neighbor. One of the things to prevent you from using your neighbor, every single person in that exam will have a different test. They're all computer generated, so no tests are going to be the same, so it won't really help you to look over at your neighbor. You can take your time. There's no rush. We're patient. We'll wait as long as necessary. We do have a time limit of midnight, though. So if you need to take your time, we just ask that you be done by midnight, because then we'll have to restart the paperwork. Double check your answer sheet. Be sure you don't omit any answers. There are 35 questions. Make sure you have 35 answers. An unanswered question is counted as a wrong answer. So if you skip one accidentally, that is considered wrong. If you don't understand a question, ask a VE to clarify. We're here to help. If you're uncomfortable or if something is disturbing you, let us know. Let a VE know. We're here to help. Mark your selection clearly on the answer sheet, or if it's I don't know if it's computer based, make sure you get everything there. If you change your answer, erase the old answer completely. We have the W5YI has what we will do is, I believe it's the W5Y. We have an overlay that we will put on top of the test with and we'll just go right down the list and verify your answers with the template. The ARL, or I can't remember exactly which one it is. We have a answer sheet and we flip to the answers and we go line by line. So if you miss one, it is considered wrong. Please don't make any marks on the question booklet. If you need to do any calculations or make any mental notes, do them on the back of your answer sheet. We have to take all the paperwork, everything that was generated for this test exam. We have to take that. We have to send that to the VEC, and then they verify and make sure everything is correct. When you've completed your exam, just keep your seat, raise your hand, or whatever the instructions that your VE gives you. Somebody will pick up your answer sheet and test booklet. They will grade your exam right there. So you will know before you leave, when you've taken your exam, you will know right then, as soon as they're done grading your exam, did you pass or fail. Do not exit the premises. There's still more paperwork. It's, paperwork is always the hard part. Just follow the instructions of your VE team. They're like I said, they're there to help. There may be others still taking the test, so if you could just kind of keep your voices quiet, that would probably be best. If you get stumped, read through all of the questions. Sometimes following the question will give you a hint. If you just can't get it, skip it. There's always that chance that while you're taking your test, another question may be asked that can give you the answer or remind you of what the answer it is that you had trouble with. As a last resort, if you're completely stumped, just eliminate the obviously correct answers. So then select what appears to be the most reasonable of the remaining answers. Don't use that method that you always hear about. If you don't know, just select C. Don't do that because that doesn't apply to this, since it is not a high. It's not what they would consider a high risk test for academia. If you become desperate, 34% of the time, all of these choices are correct. That's your odds right there. Many times, and this has always been true, including when I took my test years ago, many times the longest or most complicated answer is correct. Don't rely on these study hints as a substitute to study. You still need to study in combination with this, but those are some little tips that we've come across in the year. Review your answers one last time. You know this stuff. We've gone over it. You've read your book. Let me go back here for just a second. I don't think it said. I don't believe that it said. No, it didn't. Go with your first instinct. If you start doubting yourself, our experience as VEs shows that your first answer that you put on your answer sheet is generally the correct one. We do see time and time again where somebody had the correct answer, doubted themselves later, and went back and changed it to an incorrect one. Usually stay with your first instinct. You like I said, you know this stuff. You've gone through this class. You've gone through the book. There's people out there to help you, but you know this stuff. You have the question pool. So what you see in the question pool is what you are going to be presented with. I do want to thank the Hearst Amateur Radio Club, Hearst Racies, and also Ham 2.0. Also, our chat moderators that have been taking all the questions and everything. I also would like to thank you for participating in our technician class training. I've enjoyed it. I've enjoyed teaching, and I feel confident that if going forward, if you are ready to take your test, that you will pass it because you've utilized all the resources that we've given to you. So thank you. And like I said, thank you to the Hearst Amateur Radio Club. Thank you, Mike, for these 3 presentations. It's been almost 500 slides that he put together. So thank you for those. I will have this information available online that you can download. It may not be in an obvious spot, but I will put it out there and find a way to make it where people can find it, because it is a lot of information that can be passed, be shared.
For sure. Yeah, w5hrc.org is the Hearst Amateur Radio Club website, so it will be, when he's done with that, it will be shared up there somewhere. So, yeah, thanks for all the participation and for all the great comments. We have had a lot of really good comments in the chat. Good questions. People have really enjoyed the format of such a detailed explanation about everything. So that has been
looking
good.
for I have a field strength report somewhere in all of my files. I have it, and I said I was going to show. I'm going to keep looking for that. Hopefully, I can find it.
Cool.
Because I know anytime you say you have to do some sort of an evaluation, that can cause a little bit of panic. I'll find it. It's pretty simple. I just saw it somewhere. I just had it recently. But we'll still take questions.
Yeah. Thank you, Dan Garcia. Thank you, Rob Smith. Thank you, JD Williamson. Appreciate you guys being in here. Mongoose, thanks for joining the chat. Rhonda, thanks for joining the chat. West MC45. Siobhan Sellers. I'm sure I'm saying your name wrong there, man. Thanks for joining the chat. Appreciate Josh Marsh from North Alabama. Thanks for joining today. So we're going to do that.
Here it is. I got it.
So you got your field strength reading?
Yeah, I just want to show this real quick.
Okay. Yeah, go ahead.
So this is a field strength report that I generated online. This was done for the antenna that is directly above my head. What you do is, and I don't have the link to this website anymore, but this is just basically the information you put in. Your power, the maximum power is what I put in here. Antenna gain, how far away from this antenna, if I were standing outside, how far away from that antenna would I be? Frequency, are ground reflections calculated? Yes. Power density, that is the power density and stuff like that. You don't have to put that in there, but then it will spit out how far away do I need to be in order to be safe. 5.2 feet. Well, it's above my head. It's well more than 5 feet, and I'm definitely not. It's not 5 feet from me. Uncontrolled, my neighbors right across here, then you'd be at least 12 feet. So as long as they're outside of that limit right there, they're going to be compliant. And this is just something that I printed off because I had multiple antennas out there. So that's what that is. I said I was going to share it, and I wanted to make sure that because it sounded very intimidating. and I did that on November 15th because nothing's changed since then, but it's about to. So I have to do this again, and I'll just find the information online and plug the numbers that they asked for, and then it'll spit out the report, and I can print it and good to go.
Cool. Typing in. Okay, there we go. Cool. Okay, so following this, again, this will be, once we end the live stream here in just a few minutes, this will be posted on YouTube. YouTube processes it on their end, and then it automatically posts. It might take an hour or two since the stream's been going for, well, about 2 hours right now. So it might take a little bit of time, but this will be up on YouTube. It will be in a playlist on my channel. Let me go get that real quick for you. So there's a playlist out there for these 3 classes, and there's a playlist out there for the general classes as well. Here is a link to the playlist for the technician classes. You can go back and watch those anytime you want to, and you can put comments in the YouTube video. If you have questions later on, just go ahead and comment. I try to watch all of my YouTube video comments and respond to all the ones that I can. And yeah, Frank just posted the Discord link in the chat as well. We are in Discord pretty much all day long every day. We're chatting in Discord. Got a couple of guys in Discord that are overseas, so they're chatting all night long. I woke up this morning and had 2 or 3 stations talking about spotting each other on the HF bands. So they're like, oh, this station's over here, this station's over here. And one guy was in South Africa, and there were a couple of U.S. stations in there. So a lot of good information in the Discord chat here. So we're going to go ahead and close it down. Chris, thank you once again. I know it's been it's been kind of time consuming, but it's a little bit nerve wracking to be presenting on a live stream, because you don't really see your audience. It's not like you're presenting to a room of just like 8 or 10 people. So
it's fun. I always say that I love doing these classes. I really do. I enjoy teaching. But at the same time, it is exhausting.
Yeah.
I'll probably take a nap today just because it's a lot of time, but
Yeah.
it's a lot of fun. I really enjoy doing it. And when people say, hey, we took your class and we got our technician class or general class or one day extra, using your live stream or something like that.
Mm-hmm.
That's always, it's really nice to hear. And I'm
Mm-hmm.
just glad that, with all this COVID stuff going along, that
Yeah.
we have the opportunity and the resources to do this. And
Mm-hmm.
I've never done an online webinar like this before, but
Right.
it turned out really, really well. And it's
so.
really neat.
I think so. Yeah. Yeah, for sure. So thanks for doing that. Yeah, someone asked about an extra class, which I get that question all the time because I've had technician and general classes posted on the channel for a while. Yes, Mike N5YM, who wrote this material, is working on an extra class. It's just there's like twice as many questions in the question pool as there is as compared to the other 2. It's a much more extensive set of materials for the extra class than it is for the technician or the general class. So yes, we are working on that, and yes, as soon as that is available, I plan to record that. Whether we'll do a live stream or I'll just record it and post it, I don't know yet. Time will tell on that, but we will be doing that eventually. Hopefully it won't be too long there. So Frank just posted in the in the chat rather about my live stream tomorrow. Tomorrow evening at 6 p.m. Central Standard Time, I think it is. Today, May 2nd, 5 years ago today is when I started this YouTube channel. And now we're at like 375 episodes later, over 400 videos, because a lot of the episodes have more than one video to them. And we're just under 30,000 subscribers. So it's been a fun ride. So tomorrow I'm going to do a live stream about the 5-year anniversary of the channel, and we're going to be giving away some radios. A couple of DMR mobile radios, the Anytone D578. I've got 2 of those to give away. I've got a Connect Systems handheld DMR HT. I've got some stuff from MFJ, and going to be announcing all that tomorrow. So you guys join the live stream tomorrow, 6 p.m. Central Standard Time, and we'll be talking about that. So Okay, Chris just linked where he put the slides online at w5hrc.org/tech class slides.
I'm not there just yet, but I will. I'll get them converted,
Okay.
and I'll get them up there that way. That you can download them because they are, like I said, they are released under Creative Commons, which allows you to share. All we ask that you give attribution, non-commercial, and I don't think not non-modifiable or something like that. But
right.
Yeah, you can use them. You can teach your own class if you would like, and they'll be up there shortly. They're not there just yet, but they will be shortly.
Okay. Good deal. All right, well, we're gonna close it down, guys. Thanks for all who watched today. Hit the like button, the thumbs up if you haven't done it yet. That does help with the YouTube algorithm, and hopefully see you on the stream tomorrow night. Put your comments in the YouTube channel, and we will hopefully get some new tech. If you go test soon, as a result of watching these classes, and you get your license, let us know. Go back into the class, put comments in the YouTube channel, say, I took my test, I passed, and here's my new call sign. Really, really appreciate that. Next week, I'm going to post 2 or 3 new videos about what to do for brand new hams, what to do once you get your call sign. So be watching that too. So 73 guys, thanks everyone. Everyone have a good day, and we will catch you guys next time.